everyone, and welcome to From Brute to Best. Today we will discuss a very interesting algorithm problem, and we will try to solve that problem using recursion. The problem is very basic, but most of us, when we try to solve this problem, we basically think of brute force by default. Okay, so before starting the problem, if you are new to this channel, please subscribe to this channel. This will help me to create more videos, and if this video helps you to understand the logic and to help you thinking in a better way, do like the video and share it with your friends. Okay, now let me start with the problem. Okay, so today's problem is finding the power or calculating the power of any given integer. Okay, so for example, if I ask you to find power of let's say 4 to the power 8. Okay, so sorry, yeah, so we need to find 4 to the power 8, the value of 4 to the power 8. Okay, now the moment we see this problem, the first solution that comes in our mind, the mathematical solution, is multiplying 4 into 8 times, right? So what we will do, we will simply multiply 4, correct, and so on till 8, right? Correct. Now this solution might look correct as well as easy. Okay, but the problem occurs when we will deal with large numbers. So for example, if I had to calculate, let's say 10 to the power 15, or let me change the number. 10 is quite a simpler number, right? So let's say I have to calculate 1 million or 623 to the power 2000 or even 5000. Okay, to the power 5000, right? Now if we try to solve this problem in the conventional way, it will result as the program will take a lot of time. Basically, the first solution that's the brute force solution, which we will do, calculating 623 up to 5000 times. Okay, now to write this solution in code, what we will do, we will simply have a for loop, right? Or we will have a, let's say, variable long, right? Long, let's say, result. Okay, and result, which we will initially set it to 1, correct, and then we will have a for loop here, correct. So let me just, sorry, yeah, to solve this problem in logically, what we will do, we will, if we try to solve this problem in the brute force, how we will solve, we will simply initialize a variable let's say result with 1, correct? And then we will iterate through from starting from 1 or 0 up to the number, right? So up to the number, here number is equals to 623, right? So let me define the variables as well. Okay, so let's say my base is uh, is equals to 623, correct? Let me, okay, and my exponential or power is equals to 5000, correct? Now what I will do, I will simply loop through all the times. I mean 5000 times. We will have a iteration 5000 times, correct? And we will keep on multiplying the result, right, with the base value, correct? And at the end we will return the result, right? So this will be our brute force solution, right? Now this brute force solution, in the first glance, this may look correct, but can you see the problem here? Problem is this iteration looping through the number of exponential times. I mean same as exponential times, correct? So which is resulting the complexity as order of n, correct? So if I write the complexity of this logic, so time complexity will be order of n, correct? So n here is the value of exponential, correct? Let me, yeah, or if we change it to order of exp, I mean we don't write order in the form of exp, we always write in the form of n, just to help you understand. The complexity will be, I mean the loop will run the same amount of time as the exponential power value, correct? So the final time complexity will be order of n. Now what will be the correct solution, or what should be the correct approach to solve this problem, right? Okay, now if you can see here, the, or let's say if I can rewrite this term 623 up to power of 5000, right? What if I can tell you, or what if we can reduce the calculation or reduce the iteration, okay? And how we are going to reduce it? Okay, now same thing, 623 power of 5000, we can write it something like this: 623 power of 2,500, sorry, so 2500, right, into or multiplied by the same number again. That means 623 power of 2500, right? Okay, sorry for my handwriting, but I hope this is clear to you. So see what we can do here, or how we can break this entire calculation into two separate calculations. So the 623 power of 5000, we can write it like this: 623 power of 2500 into 623 power of 2500. So instead of calculating 623 power of 5000, if we can calculate 623 power of 2500. Then we can multiply the same value twice to get the actual result, right? Or we can multiply the same value again, so to get the final result, right? Similarly, this 623 power of 2500, we can again divide it to how much? We can again divide it to 623 power of 1250, correct? 1250 multiplied by the same number, correct? Now can you see the pattern here? If instead of calculating the whole value in one go, we can divide the task in half. So calculating the half value and then multiplying the same half with a half again to get the final result. Similarly, the half which we will calculate, that can again be divided in a sub half, and so on, right? We can further divide this 1250 to 625, then we can divide that again to half, again half, till we reach up to 623 to the power 0. And now the moment we reach here, we can simply calculate this value as 1, because anything power 0 is equals to 1, right? So here, so now as you can see here clearly, we are not calculating, or we will not calculate the entire value in one go. Rather, we will divide the full task into half, then half, then half, I mean 1 by 2, 1 by 4, 1 by 8, and so on, until we reach a base condition where we don't have to do any calculation. We can simply return a value, or a constant value, right? And rest will be taken care automatically. Now, as you can clearly see, after each iteration, I mean after every iteration, we are actually dividing the iteration, or we are reducing the iteration by half. So initially it was supposed to be 5000, then we divided it to 2500. Then we further divided it to 12,500. Then we further divided it to 625. So after every iteration, what we are doing, we are basically reducing the size by half. And if you know what the basic principle of time complexity, following this pattern, you can easily say that if we follow this approach, the time complexity will be log of n time, correct? So if we follow this divide and conquer rule, we can reduce the time complexity from order of n to log of n, correct? So how we are going to actually achieve this? Okay, so we will use recursion. Now here is one catch. Okay, so here you can see after each division, the power or the exponential value is an even number. So that's why dividing it into half is quite easy, right? Or calculate, or dividing the task in half is quite easy. But what if the number is not even? Okay, number is a odd number. So for example, 5001, right? Okay, let me not change this. Yeah, so let me just write it somewhere else. Okay, so what if the exponential power we have is a odd number, right? So for example, this, let us take the same number 623. Okay? 623 power of 5001, right? Sorry, 5001, correct? Now there's nothing to panic. This is quite easy. Now if you can see the pattern here, okay, this one or odd number we can easily convert it into an even number. Let me show you how. What we can write is 623 to the power of 5000, yeah, into 623 one time, right? Or 623 to the power of 1, correct? So this even power or exponential value, we can break it to the previous even number, sorry, the odd exponential, we can break it to previous even number and multiply it by the same base only once, correct? Now this 623 to the power 5000, we can further break it to 623 to the power 1200 into 1200, sorry, 1250, sorry, to 2500, 2500, then 2500, we can further break it to 1250, 1250, we can further break it to 623, 623 to the power 625, correct? Now again, here you can see the power or exponential value became odd. Now this we will further, this 623 to the power 625, we will further break it to 623 to the power 312 into 623 to the power 312 into 623 one time, right? So you can see the pattern, right? So whenever the value is even, whenever the value is even, we can simply calculate, we can simply calculate the value by ha calculating half of the exponential value, right? So 623 to the power 2500, and the moment exponential value becomes odd, we will still calculate the same half value, just at the end we will multiply the base one extra time, right? I hope this helps you to understand the solution using optimized way or using recursion correctly, right? Now let me quickly show you the code or a Java code with this solution. Okay, so just be with me while I will write the code. So here we are. Just to save some time, I have already created this class and a main method. Now let me quickly create our recursion method that will calculate the power, right? So for that, let me have a static method. You can create a non-static method and create the object of the class to call it. But for now, just my purpose is just to show you the solution in recursion. So I'm creating a static method. Now let's say calculate power, right? And we will have a long base and an integer exponential here, right? And so in recursion, we first add the base case. What will be our base case? Our base case will be when the exponential value becomes 0, right? The moment it becomes 0, we can simply return 1, right? And next, we can calculate the half value. We don't have to calculate the entire power value in one go. We will calculate half of that value. How we will calculate? We will simply call the function again, right? And here base will remain same. The exponential, the power value, we will divide it by 2, okay? And here we will have a check, or simply check if the exponential is even, right? Then we will simply return the half multiplied by the half again, right? Or else if it's an odd value, the power is a odd number, we will simply multiply the base one time with the calculated value, right? So this is the optimized solution of calculating power of any value, any given number, right? So let me just add some messages, print messages. Let me have the same example. 6 to the power 5000 result of is, okay? And let us call this, our base will be 623, and okay, let me add a L here, and our exponential value will be 5000, correct? Now let me quickly run this program. So it calculated, even it calculated wrongly because it's basically exceeded the boundary, right? Yeah. So let me try with a number which will result within the boundary, okay? So if we calculated this value, okay, let me run this. So calculated or result the value of 623 power of 300. If I give a odd number, let's say 295. Yeah, so it's calculating the power value correctly, right? I can change the message here just to show you, okay? So here, as you can see, every time or every next call, we are basically dividing, or we are reducing the size by half, and that's why the final time complexity of this logic or of this algorithm will be order of log n, okay? So I hope this video helps you to understand the problem and change your thinking from brute force to optimized solution, right? If this video really helped you, please like this video and share it with your friends, and please subscribe to my channel for any new video I'll upload in my channel, okay? Thanks everyone, see you in the next video.